In this video, I'm going to introduce STP and stoichiometry of a gas. Aim, we are learning to define STP. We are learning to complete stoichiometry for gases by using the volume of 1 mole of a gas. You might have seen STP already. STP, S stands for standard. You already know what T stands for and P stands for. What do you think T stands for? Temperature. Standard temperature is 273 Kelvin. If I convert this to degrees Celsius, I would have subtracted 273, so it's also 0 degrees Celsius. We will be using 273 Kelvin because temperature has to be in Kelvin for our gas problems. P, what does P stand for? P stands for pressure, which will be 1 atm. 1 atm is also 760 mmHg, which we also know is known as torr. Torr is going to be 101.3 kilopascal, which we write as kPa. What this means is that if a gas is at STP, then it is at 273 Kelvin, and typically we're going to use 1 atm. 1 mole of a gas at STP, and remember STP is 273 Kelvin, 1 atm, will occupy 22.4 liters. So what that means is we can think of this as a 22.4 liter balloon, which is a pretty big balloon, and it will contain 1 mole of gas as long as it is at 273 Kelvin and 1 mole. So if it's 273 Kelvin outside, and sorry, not 1 mole, but 1 atm, and the pressure is 1 atm, and I blow up a balloon to 22.4 liters, I know inside of that balloon I have 1 mole of my gas. So remember, at STP, 1 mole equals 22.4 liters. This is known as molar volume. Example 1. A gas that fills up a soccer ball is typically 1.5 atm, 2.1 liters, so this is pressure, volume, and temperature. How many moles of gas fill up this soccer ball? I ask myself, is this at STP? Well, I'm at 1.5 atm. Is that standard pressure? Standard pressure is 1 atm, so this is not at STP. So I cannot use molar volume. Instead, I would use PV equals nRT for this equation. Example 2. A balloon of CO2 is found to have the volume of 22.4 liters. The gas is miraculously at STP. At STP, 1 mole equals 22.4 liters. How many moles of CO2 are in this balloon? I'm at STP, so I can use 1 mole equals 22.4 liters. All I do is a conversion. I start with my given, and I multiply it by the conversion factor. So that means I start with my given 22.4 liters of CO2. I know that for every 1 mole of CO2, there are 22.4 liters of CO2 because we are at STP. Liters of CO2 cancel. I'm left with moles of CO2. 22.4 times 1 divided by 22.4 gets you 1 mole of CO2. On the back of this worksheet, there are a couple other questions. We're going to look at number 5 because it's more of a stoichiometry question. So number 5, here's our reaction. 2 lead 2 oxide decomposes to create 2 lead and oxygen gas. What is the total volume? So I'm looking for volume of oxygen measured at STP, so I know I can use 1 mole equals 22.4 liters when 1 mole of PbO decomposes. Well, I see I have oxygen in PbO. This is a stoichiometry question because I'm looking at 2 different molecules. I always start with my given. My given is 1.00 mole PbO. I want to cancel out moles of PbO, so that goes at the bottom. I'm going to be using my molar ratio here. I circled these so I would know my molar ratio. It's my coefficient of my molecule. So 2 moles of lead to oxide for every 1 mole of oxygen. Well, moles of lead to oxide cancel, but I'm left with moles of oxygen. This question is asking for total volume. So I need to cancel moles of oxygen out. How can I do that? I'm at STP, so I know that 1 mole of oxygen will equal 22.4 liters of oxygen. Moles of oxygen cancel. I'm left with liters of oxygen, so I've set this up correctly. Multiply 1 times 1 times 22.4, which will get you 22.4. We divide by what's below, so divided by 2, so that's 11.2. Divided by 1, that stays 11.2, so our answer is B, 11.2 liters.